Hello, boys and girls. Welcome back to another edition of Crush Lusher Television. All right, so we're going to continue what we did yesterday. Again, this is the last thing. You guys are doing awesome. But here is the last problem that we didn't get to. So please write it down in your notes. So region R, y equals sine x equals 0, y equals 1. Find the area of region R. R is the base of a solid made up of equilateral triangle cross sections perpendicular to the y-axis. Find the volume of this solid. Find the volume of the solid created if region R is revolved around the y-axis. And D, find the volume of the solid created if region R revolved around the vertical line x equals 5. So pause the video, copy that down. Here's the first part, pause. Here's the second part, pause. Try and do the whole thing yourself right now. Pause it and see if you can do the whole thing yourself before you watch me do the whole thing, okay? Always trying to test yourself. Here we go. Let's give it a shot. So, first we gotta do a picture. Okay, so what do I know? So I know that this y equals sine of x always goes by the unit circle. That's all I know. So like in the unit circle, boom. If this point is 1, 0, this point is 0, 1, this point is negative 1, 0. Write this down. If I'm going too fast, just pause it. 0, negative 1. This is 0, pi over 2, pi, 3 pi over 2, and 2 pi, all the way around the circle. So sine is the y value. So sine of 0 is 0, bam. Sine of pi over 2 is 1, so let's get 1 going right here. So pi over 2 is 1, and then sine of pi is 0. Sine of 3 pi over 2 is negative 1, so we go negative 1 down here. And then back to the beginning, 2 pi is 0, so it's boom. And it just continues because you can keep going around the circle forever. So you can go and keep going. But we don't need to because now we're defined by y equals sine of x equals 0. That's actually this. X equals 0. And y equals 1. Y equals 1. Oh, so here is the area right here. Cool. So what is this area? So that's going to be between 0 and pi over 2. So the area is the area under the curve. So between 0 and pi over 2 of top minus bottom. Top is 1. The bottom is sine of x dx. There we go. Cool. Questions on that? You can also do this. You can also flip it to the side like this, and you only have one top and one bottom here. And sorry, you can't see that. One top and one bottom there. So that would be, so if you find the inverse, y equals sine of x, the inverse of that is x equals inverse sine of y. Like that. So this would be the top, this would be the bottom. The bottom is just 0 here. So that would be the area equals the integral between 0 and 1. 1 here on the y, 0 and 1 of inverse sine of y dy. And these would yield the same answer. Whatever you get would be equal. Because one is in terms of x, one is in terms of y. So let's use this now for part B. Part B. R is the base of a solid made up of equilateral triangle cross sections perpendicular to the y-axis. Okay, so picture. So we got this. So this is 1, 0, 1, and this is pi over 2. So here we have triangles coming out perpendicular to the y-axis. So we have an infinite amount of little triangles, equilateral triangles. So let's get our slice going like we did before. This is dy because we are in terms of y, because this is the distance with the y. So this right here is going to be top minus bottom. Well, we just did that right here. Good thing we did that. So this is going to be inverse sine of y. And this is going to be inverse sine of y, and then inverse sine of y. So the volume of a slice is going to be 1/2 base times height, which is this area, times dy. So it's 1/2, the base is sine -1 of y, and the height, you remember 30, 60, 90? That would be, remember that? Sine of -1 of y divided by 2 times radical 3. If you forget this, just go back and look at the volume of cross sections, part 2. Volume of cross sections, part 2, and go back and look in your notes also, because we did that one before. And then dy is at the end. You see that? dy at the end. So 1/2 base, and then that's the height, because you have a 30, 60, 90 triangle. Okay? Now, we have the volume of this whole shape. We got a little pointy top, because we have all these triangles there, is going to be the integral between 0 and 1, because we're doing it in terms of y, 0 and 1, not 0 and pi over 2, that's in terms of x. So that's going to be radical 3 over 4 times inverse sine of y squared dy. Cool. Did you get that one? Hopefully you did. If not, that's okay. Let's keep going. Doing a great job. All right, so find the volume of, part C, find the volume of the solid created if region R is revolved around the y-axis. All right, same picture. 0, pi over 2, this is 1. So this is going to be revolved, let's draw your mirror, like this, like this, like this, like this. And so that is just going to be a disk. There's no hole in the middle right there. And this is going to be your radius. This is going to be your radius, which you've done multiple times before already in this problem. That's going to be inverse sine of y. So the volume of a slice is going to be pi r squared dy, because this is the infinite amount of really small distance right there. So equals pi times inverse sine of y squared dy. And so my final volume of this shape right here, where it's revolved around, is going to be the volume between 0 and 1 of pi inverse sine of y squared dy. There we go. Nice job. Let's keep it going. Part D. Find the volume of a solid created by revolving region R around the vertical line x equals 5. All right. Picture, picture. 1, 0, pi over 2. So 5 is going to be way over here. X equals 5. This is 3.14 divided by 2. So this is like 1 point something. So 5 is going to be over here. Dot, 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 imaginary line. And so we got this mirror image right here. So this is region R. And so we go outside to outside, inside to inside for the whole. Outside to outside, inside to inside. All right, so it looks like this. So we have our radius comes from this direction. Little radius comes from that direction. So you always have to flip it this way, looking at it this way. So we have the big R, which is 5 and 0. So it goes from 5 to 0. So the big radius is 5 minus 0. The smaller radius is going to be 5 minus this curve. So 5 minus the curve, that's this radius here. That's the internal radius. So the small radius is 5 minus the curve, which is negative inverse sine of y. Cool. All right, so this is dy. The volume of a slice is going to be pi times 5 squared minus pi times 5 minus inverse sine of y squared dy. All right, last step. The full volume of this whole shape is going to be the integral between 0 and 1 of 25 pi minus pi times 5 minus sine of -1 of y squared dy. There you go. Big circle minus little circle. Got to cut it out. Cool. Nice job. Hopefully you got all those right. Look at the instructions for what to do next. Keep it going. Nice job, everybody. See you later.